All right, let's solve a puzzle that has probably stumped every single one of us in the kitchen at some point. Baking soda versus baking powder. What is the actual difference?
You know how it is. They look exactly the same. They both promise to make your baked goods rise, but grabbing the wrong one can turn your dream of fluffy pancakes into, well, a sad, flat tortilla. So what's really going on inside that batter? To figure it out, we need to dive into a little bit of kitchen chemistry.
To solve this mystery, we've got to start with the OG, the original solo artist of chemical leaveners, baking soda.
Okay, so baking soda is just one single thing, a chemical base called sodium bicarbonate. By itself, it doesn't really do anything. It's just kind of waiting. It needs an acidic partner to get the party started. We're talking ingredients like buttermilk, lemon juice, yogurt, or even things like honey.
You'll definitely recognize this reaction. It's basically that volcano experiment you did in science class, right? The second the base and the acid meet in a liquid, they start fizzing like crazy, creating tons of carbon dioxide gas. In your batter, those little CO2 bubbles get trapped. Then, when they hit the heat of the oven, they expand, and poof, that's what makes everything light and airy.
So, if baking soda needs an acid from your recipe to work, what's the deal with baking powder? Well, this is where things get really clever. Baking powder is the all-in-one, ready-to-go solution. It brings its own acid right in the can.
Think of baking powder as a pre-mixed team of three. First, you've got the base, the same sodium bicarbonate as in baking soda. But then, it's got its own powdered acid mixed right in. And that third ingredient, the cornstarch, is absolutely crucial. It acts like a buffer, keeping everything dry and separating the acid and base so they don't react prematurely in the can.
Now, the very first baking powders were single-acting. That meant the second you added water or milk, the reaction started and you had to literally race to get that batter into the oven. But today, almost all the baking powder you buy is double-acting, which is just a brilliant innovation that gives you way more control. So think of it like a two-stage rocket for your cake. The first stage fires off right on your countertop when you mix everything together. You get an initial burst of gas that creates the basic bubble structure. But the second, much more powerful stage is heat-activated. It waits until it's in the oven and then, bam, it releases the rest of the gas, giving you that huge oven spring that guarantees a super fluffy result.
And you know, this invention didn't just make baking a little bit easier, it completely revolutionized it. It turned what was once a multi-day ordeal into something anybody could do in an afternoon.
I mean, can you even imagine that now? Before the 1850s, making a cake was so much work. You either had to rely on wild yeast, which was super unpredictable and could take a whole day to rise, or you used harsh chemicals like pearlash, which was literally made from wood ash. Yikes!
The road to the baking powder we know today was this whirlwind of innovation. It really kicked off in 1843 in England with Alfred Bird, who was just trying to create a yeast-free bread for his wife. Then, a Harvard chemist named Eben Horsford perfected the formula here in the US, and by the 1860s, he had created the double-acting powder that is pretty much the global standard we all use. This was a massive game-changer for home kitchens everywhere.
Okay, so we've got the science and the history down. Let's get practical. Why on earth do some recipes call for just soda, some for just powder, and some for both? Well, it's all about finding the right chemical balance.
The rule of thumb is actually pretty simple. Just look at your ingredient list. If the recipe already has a strong acid in it, like buttermilk, yogurt, or lemon juice, you'll use baking soda to react with it. But if your liquids are neutral, like regular milk or water, you need to bring your own acid to the party, and that's when you reach for baking powder.
But here's where it gets really interesting. Lift is only half the story. Your choice between soda and powder is also a secret weapon for controlling the final taste, the color, and even the texture of your baking. This is where the real artistry comes in.
See, because baking soda is a base, it makes your batter more alkaline. This speeds up something called the Maillard reaction. That's the amazing chemical process that's responsible for deep, beautiful browning and those rich, roasted, nutty flavors. Think of a perfect, dark, golden chocolate chip cookie. On the other hand, baking powder keeps things more neutral. That leads to a lighter color, a more delicate flavor, and a springier texture, like in a classic vanilla cake.
So, after more than 150 years, you'd think we'd have perfected this stuff, right? But the story's not over. The future of what's in that little can is being shaped by totally new consumer demands and some really fascinating technology.
First off, let's just talk about the sheer scale here. This isn't just about your home pantry.
The global market for these leavening agents is absolutely massive. It's projected to hit over $10 billion in the next decade or so, and that's all fueled by our collective, worldwide love for baked goods.
And this is a truly global thing. While North America and Europe are still huge players, the biggest growth is actually happening in the Asia-Pacific region, as Western-style baked goods just keep getting more and more popular all over the world.
So what's next? Well, a big focus is on what the industry calls clean leavening. We all want healthier, more sustainable options with ingredients we can actually pronounce. At the same time, food science is pushing into some really cool territory with things like nano-encapsulation. We're talking about creating microscopic coatings for the ingredients, which allows for an even more precise, perfectly timed release of gas. It's high-tech baking.
So when you think about it, we went from using wood ash in the 1700s to a Harvard chemistry lab in the 1860s. That simple search for the perfect rise has totally transformed the food we eat. And as science keeps evolving, you just have to wonder, what's the next amazing leap in baking technology going to be?
Don't forget to like and subscribe for more How Meets History.